All right, so we're going to do something called a definite integral. Before we get stuck into the heavy-duty algebra that it takes to do the definite integral, we want to know what it's good for. So let's take a look. So here's my function, 0.5x squared plus 2. And I want to find the area under the curve between x equals 2 and x equals 6. That's what the definite integral is going to be good for. Now, in the past, you might have used the trapezoidal rule. So you might just draw a trapezoid between x equals 2 and x equals 6 and find an area of 48. That's just one trapezoid. Now, if you increase the trapezoids, you're going to get a more accurate answer. But it's always just going to be an estimate. The estimate might get really good. Now, I'm using 19 trapezoids there, and if you think back to the algebra or the calculations you would have to do 19 trapezoids, that would be a huge pain. The definite integral is going to let us do something far, far simpler than that. Not only that, it's going to give us an exact answer, not an estimate, like the trapezoidal rule does. So the exact answer is actually this, 42.67. If I change my rounding here, I get the feeling it's 42 2/3. So we'll be able to come up with that algebraically using the definite integral. Now, if I want to write the definite integral down for this particular circumstance, it will look something like this. So this says the definite integral between 6 and 2 of 0.5x squared plus 2 with respect to x. Now, I'm not going to show you how to calculate that. That's for another video. But that's how we write down that we want to find the definite integral between those two values. Now, I can sort of generalize this a little bit and write it down as this. The definite integral is equal to integral BA f of x with respect to x. Now you'll notice that I'm putting BA, not AB, because it's important that the higher number, the number further to the right, goes at the top and the other number goes at the bottom. That's the definite integral. That's what it's going to be useful for. Now let's just calculate one in a future video.